So this lesson will be on Unit 1, Part 2, the multiplying of polynomials is the next big part of your assignment this week. I'm just going to kind of walk you through these notes a little bit so you can also use these as a way to go back over what we did this week. So see if we can kind of get that going here. So again, back to multiplying, some more vocabulary to kind of talk about. So in multiplying, there's a few other words we need to start picking up on. So notice how we have 3 times 5 is equal to 15. The numbers connected by multiplication can also be called factors. So see how this 3 and 5 are connected by multiplication? So that 3 and 5 are referred to as, they're the factors. Now the answer to the multiplication problem is called the product. So notice how the answer is 15. 15 is referred to as the product. So 15 is the product. So taking this to algebra and working with polynomials. So if I'm multiplying a monomial by a monomial, since they're connected by multiplication, each monomial is so-called a factor. Things connected by multiplication can be called factors. So notice how these parentheses are identifying this monomial and these parentheses are identifying that monomial. Since these two monomials are connected by multiplication, we call them factors. So when I have 3x times 5x, the factors are, of course, the 3x and the 5x. So another thing to pick up on is when you're multiplying, everything is connected by multiplication. The pieces can be rearranged and regrouped. In math, we call that the commutative property is the rearranging property, and regrouping is called the associative property. So multiplication has the ability to do both of those. So notice how I'm allowed to recognize that this 3 and this x are connected to multiplication. The parentheses means this monomial is connected to the other monomial by multiplication, and that 5 and x are also connected by multiplication. So all the pieces are connected by multiplication. In multiplying a monomial times a monomial, we're allowed to move the parts that go together. So I'm allowed to do this in my head or on paper. I'm going to show it on paper. So I'm going to regroup and move the 3 and 5 together. And I'm also going to regroup and put the x's together. So I'm allowed to make this turn into this. And then I could just piece these together. We know that 3 times 5 is 15. And another way to write x times x is just simply x to the second power. And so that's how we actually multiply a monomial times a monomial, is we move the pieces around that go together and we simplify along the way. Because remember, the answer's got to be written in as fewest symbols possible. So I look at this next problem. The factors of 7x squared times 2x cubed. Notice how these monomials are going to be also called the factors. So the factors of this expression are actually the two monomials. So 7x squared is the first factor, and the 2x cubed is the second factor. So when multiplied, I'm allowed to do this, and I'm going to show it on paper, but we're allowed to regroup where the numbers can go together. So that 7 times 2 can go together. And this could be a mental step. And the x's can go together. And so we have x squared times x third. Now we just have to do a little bit of cleaning up. So 7 times 2 is really the same thing as 14. So we have that. That's the product of 7 times 2. And this x squared times x to the third, we really can't do much there except clean it up. Remember, x squared just means x times x. And we're multiplying that by x times x times x. So really what we pick up on is there's 1, 2, 3, 4, 5 x's connected by multiplication. So we use exponents for that. So we write that as 14x to the fifth. So when we start multiplying expressions like this involving exponents, we notice that we actually are adding the exponents in this situation. So when you have what we call same bases, you actually can add the two exponents to get the answer of that x to the fifth. So when I'm multiplying with exponents, what we're pointing out to you then is exponents are actually added to be simplified. So we're actually adding those exponents. Even though this says multiplication, we're simplifying, remember, and what this means is if there's 7 x's here and you're multiplying by 4 more x's, how many x's are present? That actually would be there's 7 present and there's 4 present. That's actually addition. So we add the exponents, and that would be x to the 11th. So if the bases are the same, we actually add those exponents to simplify. So if I have x to the 3rd times x to the 4th, I'll pause a second here, let you kind of think about that one. Or better yet, you can pause the video anytime you want and work these problems out for me. But notice how again we have these two bases. So I have this x and I have this 3 plus 4 because it says how many x's are here? There's 3. How many x's are here? There's 4. So there's 3 and 4, which makes a total of 7. So I can write that as x to the 7th. So I'm going to pause for a second here. If you want to take a breath and so I'm back. Continue on with another thing we should be familiar with when we're working with multiplication is we're going to do a lot of multiplying with positive and negative numbers. And something to deal with in multiplication is, you know, this reads as a -5, and an equal sign also means the same as, and this actually reads as the opposite of 5. So as a note here, this statement here using math symbols translates into this. As a, I should have had a 5 there. Let me fix that real quick here. All right. There we go. So this reads -5 is the same as the opposite of 5. So in multiplying with negative numbers, what we're allowed to do actually is pull the negative sign out and put it out in front. And then what happens is the negative symbol turns into the words, this little 3-word phrase, the opposite of. So this over here reads as a -5 times a 2. But what we're allowed to do is pull out the negative and do in parentheses 5 times 2. So what this allows me to do is go 5 times 2, which is 10. And then this actually means to take the opposite of a 10. So we learned that taking the opposite means just to change the sign. So since inside is a positive, that turns into a -10. So this is the same thing as this, and this is the simplest form of that. So when we multiply -3 times a -4, the way we do this is actually we pull the negatives out, and now they become opposite symbols. So then we just have to multiply 3 times 4, which would be 12. So what this tells me to do is it tells me to actually take the opposite twice. So what's inside here turns into a 12. That 12, I'm sorry, turns into a -12. But then you got to take the opposite of that -12, and it flips back to a positive 12. And as we said earlier in last class, a negative and a negative make a positive when you're multiplying. So what I suggest here when you're multiplying with positive numbers, think like a light switch. So when there's when you're multiplying positive numbers, if there's an odd number of negatives, the answer will actually be negative. So notice how if I have, say, a -2 times a -2 times a -2, notice how there's 1, 2, 3 negatives. That's an odd number of negatives. If you think light switch, one negative changes it to a negative, but that second one flips it back to a positive, and that third one flips it back to a negative. So the answer is going to be a negative. And then 2 times 2 is 4, and 4 times 2 would be 8. So I'd end up with the -8. So if there's like 1 negative or 3 negatives or 5 negatives in a multiplication problem, an odd number of negatives will always leave the answer as a negative. Now, if there's an even number of negatives, the answer is actually going to be positive. So if I have, say, a -2 2 times -2 times -2 times -2. Didn't get that down very well. Let me erase that. Make that a little bit neater. So times another -2. Notice how there's 1, 2, 3, 4 negatives. So like a light switch, negative, positive, negative, positive. It just goes back and forth, and it ends up on the positive switch, if you will. So it's a positive answer. So all I really got to do is do all this multiplication, and I can kind of do it in pairs. 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 turns into 16. And as we said, 4 negatives make it a positive. So I kind of throw the negatives out, focus on just the numbers, and then come back and place the sign as a positive answer. So again, this may be a good place to kind of pause the video and stretch for a second. So as we move into multiplying numbers, something else that's important to pick up on as we move into algebra is the different types of ways to model multiplication. I'm going to model what's called the area of a rectangle model. If you recall, the area of a rectangle is length times width is equal to the area of rectangles. So note, L and W can also be called factors since they're connected by multiplication. So when I use the word factors, this means I'm involving multiplication. So if I look at the problem 12 times 10, I can represent 12 times 10 using the rectangle as a model. So it doesn't matter where you put the 10 and 12 because this is just a model, but my habit is the shorter side is the shorter number and the longer side is the longer number in this case. So I have 10 times 12, and 10 times 12 would be 120. Now remember, when you have 12 times 10, we learned that when you multiply by 10, I can do that rather quickly because multiply by 10 just means add on a 0. So that just becomes then 120 without a whole lot of effort. So some things to recall: when you're multiplying by 10s, you're really just adding zeros to the end of the value. Something else to pick up on though is trailing zeros mean you're multiplying by 10. So for instance, if I give you 600 times 20, notice how there's 2 trailing zeros here and 1 trailing 0 there. That means we're actually multiplying by 3 tens. So this problem can be rewritten as 6 times 2 times 10 times 10 times 10. We know that 6 times 2 means 12, 10 means add a 0, 10 means add a 0, 10 means add a 0, therefore the answer is 12,000. So what we learned in math like this is when I multiply 600 times 20, all I gotta do really is multiply the front numbers. 6 times 2 is 12, and then those trailing zeros, we just stick them all on the end, and we're able to do that math rather quickly. So if I have a problem like -50 times -30, the only math to really do is 5 times -3. We know that 5 times 3 is 15, and since there's only one negative, it's going to remain negative. So that's going to be -15. And also how there's 2 trailing zeros. So we would put those 2 trailing zeros down, and the answer would be -1,500 or -1,500. This next example, notice how an area model can be used to organize math of this nature. 3 times 245. Like I said, if it was in the real world, I'd probably be using a calculator. But we're going to show you how to do a little bit of this math actually using some fun techniques. So again, I'm going to try to draw this rectangle here. So we're going to use this area model. So the 3 and the 4 become the factors or the edges, because you remember the edges are like length and width. It doesn't really matter where I put them, but I usually like to put the small number on the edge and the big numbers across the top. Now, the way we're going to do this, though, instead of putting 245 across there, we're actually going to break 245 across apart, because I want it to be math that's a little bit easier to deal with. So I'm actually able to use place value and pull 245 back apart. Again, this is the simplest way to write it, but sometimes it's better to write things the longer way too. So 2 means 200. The 4 means 40. And the 5 is just 5. So what happens is this area model actually gets partitioned into 3 rectangles. So now what we want to do is we want to find the area of each rectangle. So we have 3 and 200 would be the measurements for this rectangle, and 3 times 200 would be that would be 600. Then to find the area of this rectangle, we have to multiply 3 times 40. 3 times 4 is 12, and we stick on that 0. That would be 120. And then 5 times 3 would be then 15. So to find the total area, we still have to add all these values together. So 600 plus 120 would be 720 plus 15. So 720 and 15, that would be 735. So in this problem here, 3 times 245 would be the same thing as 735. So these would be my factors, and that would be my product. But to get this product, I actually could organize it in this fashion. Now, how does this tie into algebra? Algebra can be modeled in many ways. So I'm going to pause for a second here and show you where this takes us. You can do the same. So what happens is the area model becomes what we call the distributive property. So the distributive property involves multiplying through addition. And when you do this, remember the parentheses are used to represent multiplication here. So when I look at this problem, there is multiplication and addition present. Now you may remember PEMDAS as well. Please excuse my dear Aunt Sally. We've learned that what we call the order of operations. So if I was given this problem, we've learned that really what you do is just, since those are like terms, if you will, 4 plus 2 would be 6, and 3 times 6 would actually be 18. That's not the distributive property. That's the order of operations. So if I look at this problem right here, the way the distributive property works is you actually got to multiply the 3 through the parentheses. So it's a good idea to kind of use these little loop-de-loos to kind of help you model your multiplication. Because remember, the 3 is connected to the parenthesis by multiplication. So this is actually 2 multiplication problems. So to do this, we're going to have 3 times 4 plus 3 times 2. That's what I mean by the distributive property. And again, if I continue working this out, that 3 times 4 would have been 12 plus 6, and 12 and 6 would still give me 18. So I get to the same answer. But this way, since I multiplied through addition, let me see if I can spell distributive property. So distributive property. We'll just leave it short for distributive. So if I distribute, that kind of means multiply through the parentheses. So if I look at this next example, notice I have 5 times 17. What I want to do is use the distributive property. But to use the distributive property, there's got to be multiplication with respect to addition. So see the multiplication, but inside the parentheses has got to be addition. So I'm allowed to change 17 back into an addition problem. The easiest way to break it up is just use place value. So the 1 really means 110, or we just call that a 10, plus then 7. And that's the same thing as 17. From there, I can now apply the distributive property. So the distributive property means multiply through the addition. So what I'm actually doing is going 5 times 10 and 5 times 7. So that's kind of what we're doing here. So 5 times 10 would be 50. Plus then 5 times 7 would be 35. And 50 and 35 would be then 85. So that's how I could do this problem using the distributive property. And that's how we're going to be approaching some of the algebra questions, is using the distributive property. So let me catch your breath again. Y'all can do the same. So now we're going to get into algebra, which means we're going to start working with these monomials and polynomials and binomials and trinomials and all those fun words. So in algebra, again, the distributive property comes in handy because it allows us to sometimes remove parentheses when we couldn't do it otherwise. So when multiplication and addition are present, this can be possible to remove parentheses. For example, if I want to multiply a monomial by a binomial, also note though here, there's this word factors again. Factors are connected by multiplication. So it's also important to identify that the monomial is one factor and the binomial is actually another factor, because they are connected by multiplication, these parentheses. So notice that monomial 2x is actually one of the factors, and this 5x squared plus 3x is the other factor. Now, what we want to do though is we want to multiply this out. But notice why we need the distributive property. If you look at the binomial, 5x and 3x are not like terms. Even though they have the same variable, they do not have the same exponents. So we can't do what's inside the parentheses. So we're stuck with this binomial. But what we can do to make these parentheses go away is I'm allowed to multiply through those parentheses. And when I multiply through those parentheses, the parentheses are no longer in the problem. So that means I have 2x times this 5x squared. Plus then this 2x goes with this 3x. So that's 2x times this 3x. Now, when you're multiplying a monomial by a monomial, as we said earlier, a monomial times a monomial, we're allowed to regroup and change order and all that, rearrange and regroup. So if I rearrange, the 2 and 5 can go together, and 2 times 5 would be 10. And the x and x squared would go together. Remember, that really means there's an x to the first there. So that means there's 3 x's altogether. So that becomes then 10x to the third, plus then I have 2x times 3x. So again, since this is a monomial times a monomial, we're allowed to rearrange things to go together. The 2 times the 3 would give me my 6. And x times x is the simplest way to write that is simply x to the power 2. So we have our answer there. So this next one we want to look at is got some negative numbers and stuff involved here. So let's see how we can attack that. So we have bring that through here. So see if we can do this here. So I have a negative 3x to the fourth times 6x squared. So negative 3 times negative 6 would be negative 18, because remember, we could rearrange and do that. So I can kind of do this in my head, negative 18, and then x to the fourth times x squared would be x to the 6. Now, if you multiply a negative times a negative 2, a negative 3x to the fourth times negative 2x, that's negative 3 times negative 2. That's going to be a positive 6. X to the fourth times x, that's going to be actually x to the 5. Okay, so that would be your answer. And oh, by the way, the monomial and the binomial, those are our factors. So let's make note of that as well, that negative 3x to the fourth, that's my monomial, and that 6x squared minus this 2x, those are my two factors that are being put together. And again, we're allowed to use the distributive property to remove those parentheses. So I'm going to pause again. So this next part, we want to get into multiplying a binomial by a binomial. And this can also be organized by using what we call the rectangle model or a four square concept. What I mean by four square, when you multiply a binomial by a binomial, all you need are 4 squares. So we can cut that up into 4 pieces. Now to have a binomial though, this is not a binomial, that's a monomial. To have a binomial, we need 2 things connected by addition. So using place value, I can break that into 20 and a 3. And 41, we can do 40 and a 1. So 20 and 3 become my terms on, I usually put them on the left side there to start with. The first one I put on the side, and the second one I always put on the top. It doesn't matter, that's just my habit. So the 20 is the first term, it goes there, the 3 would go here. And the 40 is one of the terms, and the 1 is the other term. So they go here. And so what we need to now do is kind of figure out each one of these little boxes. So to do that, this 20 and this 40 have to go together to give me that. So that's going to give me then this 800. 20 times 1 is going to give me this box, 20. And then to get in this box, 3 times 4 is 120. And 3 times 1 would be 3. So we need to now find the total area, which means we have to now add. So that's how this is kind of multiplication, because we're doing that first, and then we're finding the total area. So 800 times 120 is 920. 920 plus 20 is 940, and 3 more would make 943. So this would become then 943. So 23 times 41 would be 943. Now, again, if I just wanted the answer, I would just put that in the calculator, but I want to show you that there is some creative thinking that you can do on paper as well that kind of makes it fun and engages your brain a little bit more. So another way to do this in algebra is, instead of using what we call Foursquare, they like to use what's called FOIL. FOIL is another way to multiply a binomial times a binomial. And what FOIL stands for is, the F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So to make a binomial, again, I can break this apart into 20 and a 3, and 41 and a 40 and a 1. So I can approach this problem writing it like that. Looks more algebra there. What we do again is, FOIL is basically a way to say distributive property, but it gives you a pattern. So the first just means the first term goes to the first term. So the first term of each binomial goes together. So the 20 goes to the 40. And then the outer means the 20 goes to the outside of the other one. So the 20 and 1 go together. And then what we do is we then go to the I, which means we now turn our attention to the 3. The 3 goes to the 40. We call those the inner terms. And the 3 goes to the 1. Those are the last terms. Now remember, when you're using FOIL, this is all multiplication at this point. So what I'm doing again is, the first terms is the 20 times the 40, which would have been 800. And then 20 times 1 would be a positive 20. And then I move to the inner terms. 3 times 40 would be 120. And then 3 times 1 would be positive 3, or 3. So then we add all this together, and 800 plus 120 again is 920, plus 20 is 940, plus 3 is then 943. So we get the same answer, just organizing it different. So what happens is, as we move forward, there's 2 strategies to multiplying a binomial times a binomial. The organizer one is called Foursquare. The more algebraic looking one, or more what we call distributive property, is the FOIL. So we're going to multiply x minus 3 times x minus 4. We're now going to actually do some algebra looking things, because notice that x minus 3 times x minus 4, these binomials, each one of them cannot be simplified. There are unlike terms here, and those are unlike terms there. So we're stuck with these binomials. But we can remove the parentheses by using these 2 models. So notice how x minus 3 is one of the factors and x minus 4 is the other factor. Because remember, factors are connected by multiplication. And notice how it says a binomial by a binomial. So this binomial is one of the factors, and the second one, the x minus 4, is the second factor. So those are what we call our factors here. Now, to multiply a binomial times a binomial using 4 square, cut my thing up. So the x minus 3 becomes my one side. So that means actually we have an x and a -3 on my terms. There, they go there. Instead of saying x minus 4, my terms are actually an x and a -4. So that goes across the top. So then we turn our attention to working the inside of this. So x times x is simply x squared. X times -4, we usually write the coefficient first, so -4x. -3 times x is just, -3 times x, or -3x. And -3 times -4 is a positive 12. Now, we're supposed to add these together, but remember, we can only combine like terms. And since we're dealing with polynomials, it's a good idea to start with the highest degree, working down to our lowest degree. And you remember, the degree is the exponent. So notice how this 2 would be the degree of this term. The -4x and the -3x, they both are degree 1s. And notice that the 12 doesn't have a variable. That means its exponent was 0. That was x to the 0 there. So its degree is 0. So the degree is a 2, a 1, and a 0. So I really focus on the x squared first. And since it has no like terms, it just comes in. And then these would be my next two terms to put together. And again, you're combining these together, that's adding. So we just focus on the coefficients. A -3 and a -4 makes that -7x. And then the 12 does not have a like term, so plus 12 drops in behind it. And so that would be our result using 4 square. Let's see here. Now, multiplying the same problem out using FOIL. Now, remember, FOIL actually, okay, hold on a second here. So, using FOIL here, let me try that again. We're going to have, F O I L. So remember, the F stood for first. Try it again. First, the O stood for outer, and the I stood for inner, and the L stood for last. And the best way to kind of model this, of course, is just trying to using these little loops to kind of keep you organized. So the first means the X goes with the X, and then the O means the X goes to the -4. That's the outer terms. And then I can turn my attention to the inside. So I now do my loops underneath. The -3 goes with the X, and the -3 goes then with the last terms there. -3 and the -4 go together. So as we do this problem, we start with the top loops. So X times X is this X squared. And X times -4 would be, we just write that as -4X. -3 times X, -3X. Because again, when using FOIL, this is all multiplication to start with. So -3 times -4 is actually a positive 12. Now we're getting into what we call like terms. So if I'm doing like terms, if you want to use the circle method, you can. But there's your X squared, and then you have your -4X and your -3X and your 12. Those are your 4 terms. But you can only put together what we call like terms. So the X squared does not have a like term, he just drops in. The -4X and -3X makes then that -7X. And then we have that 12 there. So X squared minus 7X plus 12. That becomes the answer to that binomial times a binomial. It just turns into actually a trinomial. So if I want to multiply this out using FOIL, so again, we have our FOIL, first, outer, inner, last. So again, I like to use my little loops. So the x times the x times the 6, that's the first and the outer. -3 times x are the inner, and -3 times the 6. Those would be my last terms. So as we put that together, that's going to become then x squared. X times x is x squared. X times 6 is going to be a positive 6x. -3 times x is -3x. And -3 times 6 is then a -18. So again, our like terms, the x squared does not have one. The 6x and -3x go together, and that's going to be a positive 3x. And then at -18 would come on down. Because remember, if you're adding integers, 6 and a -3 are different sign. That means it's a subtraction problem. 6 minus 3 is 3, but since the 6 is more positive than the 3 is negative, then it remains being a positive answer. Okay. So again, we're going to use FOIL to multiply this expression out, this binomial times this binomial. My loops are a little flat there. Then we have this goes through here like that. So first, outer, inner, last. So we have those multiplications lined up. That just reminds me that we have to do 4 multiplications. That's why I like 4 square as well, 4 multiplications. So let's see if we can get this to happen for us here. So I have to multiply 3x times 5x. So remember, we rearrange things. 3 times 5 would be 15, and x times x would be x squared. 3x times -2 would be -6x. Then I have 1 times 5. 1 times 5 would just be 5. That would be 5x. And 1 times -2 would be then a -2. So again, the 15x squared does not have a like term. The -6x and the 5x are like terms. That would give me a -1x, or we just call that -x. And the -2 would slide back down. So remember, the 15x squared is the highest degree term. The -2 is the lowest degree term. So the 15 is called the leading coefficient. The -2 is actually referred to as the constant, as far as some things that we talked about. So let's look at multiplying a binomial and a polynomial. This is no longer FOIL because we actually have a binomial and a trinomial, and FOIL only works for a binomial and a binomial. So I can do this 2 ways though. The area model, where this factor goes along this side. So x and -2 go here. And the second factor goes across the top. So that x squared and that 4x and that -3 go across the top. And this partitions the rectangle into 3 sections there and to across for a total of 6 sections. Now to find the area of this, we just multiply each individual box. X times x squared would be x to the 3rd actually. X times 4x would be 4x squared. X times -3 would be -3x. Now we do this box. -2 times x squared would give me my -2x squared. -2 times 4x would be -8x. And -2 times -3 would be a +6. Now, the cool thing about the area model is it organizes things nicely. There's the x cubed, and if you kind of go diagonally a little bit slant, you'll see your like terms are lining up there. So that kind of lays things out for us in a nice organized manner. So the x cubed, that's our highest degree, comes first. 4x squared and negative 2x squared is going to give me my positive 2x squared. Negative 3x, negative 8x is going to give me my negative 11x. And then that 6 comes along for the ride, so plus 6. So that would be our answer to multiplying that binomial times that polynomial. So when I multiply x minus 2 times x squared plus 4x minus 3, this time though, let's use the distributive property. Remember, the distributive property is basically this x has to go through each piece. And then this negative 2 has to go through each piece. So there's actually going to be 6 multiplications that we have to do. So if I go x times x squared, that's my first loop, that's x to the third. X times 4x, that's going to be a positive 4x squared. X times negative 3 would be negative 3x. Now, this could get long horizontally, so what I'm going to do is drop down when I do this next one. Negative 2 times x squared is negative 2x squared, and I'm going to put it under its like term. The 4x squared and the negative 2x squared are compatible, so I'm going to put them underneath each other. And negative 2 times 4x is going to be negative 8x, so I put those underneath each other. And negative 2 times negative 3 is a positive 6. So again, I'm just adding like terms. So the x to the third drops down. 4x, and again, you can't say take away 2x squared, but I usually look at it as 4x squared and a negative 2x squared. So that really means 2x squared. And a negative 3 and a negative 8 makes a negative 11x. And that plus 6 comes down. And that would be doing the problem using what we call a distributive property. But also, you don't have to write stuff horizontally. You can lay things down vertically. If you recall, that's how we kind of do a lot of addition anyway. If the numbers get too big, is we start to use things going down the page as opposed to across the page. We're now getting into the bonus round. This is not required by you to do. So if you've had enough math for one day, feel free to stop. But I'm going to add a few of these questions to your section, but they're not required to be done. But if you're moving on to math, or you just like to do math for fun, here's some things that I'm going to try to explain in a short time. But a lot of this, you need to see a lot more of it then. So I'm just kind of more like expose you to some things later on. You may be able to see, hey, wait a minute. So there are special products. There's also what's called the difference of squares. If you look over here, a squared minus b squared, this represents what we call a difference of squares. There's this a squared minus then this b squared. So there's the subtraction, that's what difference means, and these two terms are squares. So there's a formula that applies to this. If your problem looks like this over here, if you have a problem that looks like a minus b times a plus b, then we actually can apply this formula over here, a squared minus b squared. So if we look at this example, x minus 3 times x plus 3, notice how this kind of meets this pattern over here. But instead of using an a, they're using an x. So a actually equals an x. Instead of a b, we have these 3's here. So b is actually 3. So what I can do is I actually can apply this formula, a squared minus b squared. So a was actually x, so I have x squared minus then b was 3. And so I can go x squared minus 9. Now I could have done this problem using FOIL if I wanted to. So I don't need this special product, but if you recognize this, it actually saves you time because all you gotta do is square the x and square the 3 and put a subtraction sign between them. And that's much faster. But you could still use FOIL through this as well and get the same answer. I'm not going to do FOIL here. Don't quite have enough room. But as a shortcut, if you recognize this x minus 3, x plus 3, all you got to do is square the first term and square the second term and put a subtraction sign between them. So it does have this x minus 5 and this x plus 5. That meets this pattern up here. So all you really got to do is go, hey, that a is really an x and that b is really a 5. So all you got to do is square the x and square the 5. And that gives you then this x squared minus 25. So I look at this x minus 7 times x plus 7. Notice how it meets that pattern. So I got to do square the x squared, square the 7. 7 squared is 49, and make it a subtraction problem. X squared minus 49, and you don't have to use FOIL or anything. So see what you think about that. Something else we have is if we have something in the form of a plus b squared. Sometimes these are called perfect squares. What I can do is there's a formula that says, hey, square the a, the first term, multiply the two terms together, a times b, and then multiply that by 2, in other words, double it. And then you square the second term. So a perfect square, in other words, a binomial squared is going to actually give you this 3-termed trinomial by using that pattern. So let's not look at this one just yet. Let's look at this x plus 2 squared. That kind of fits this formula here. So notice how this x actually is where the a is, and instead of a b, we actually have a 2. So what this is saying do is you square the x, there's x squared. What you do is you multiply the 2 times the x together, and then you multiply by 2. So that's going to give me this 4x. And then you're going to square the 2, and that's going to give me a 4. So notice how I have x plus 5 squared. To do this problem without using, if I was going to use FOIL, that would actually be x plus 5 times x plus 5. Because that exponent means there's 2 of that factor. And the factor this time is actually a binomial. That means there's 2 of these binomials there, those x plus 5s. And I could use FOIL on that. So this special product you don't really need, but it's kind of cool if you remember these patterns. If you got a really good memory, you can knock this stuff out without a whole lot of trouble. So to do this, there's actually 3 moves. You square the x, there's the x squared. You multiply the 5 times the x together, and then you have to multiply that by 2. So 5 times x times 2 would be that 10x. If you square that 5, that would be 25. So we end up within this x squared plus 10x plus this 25. So if I have x plus 9 squared, there's 3 moves. You square the x squared. You multiply the 9 times the x, and then you double it, or in other words, multiply by 2. 9 times x is 9x times 2 would be a positive 18. So it's going to be an 18x. And then you square the last term. 9 squared would be 81. So that would be that. Now, with the subtraction, notice the middle term is actually going to stay negative this time. Notice the last term is still going to be positive, though. Okay, so that's where the trick is there. And again, you can see this better if we do a little bit with FOIL. You can kind of start to see that more so. So x minus 1 times x minus 1 is what that means. And notice how you do have x squared, you have a negative x, and you have a negative x, and you have a negative times a negative, which makes a positive 1. So you have this x squared minus this 2x plus this 1. That's using FOIL, if you will. Notice how the middle term remains negative, but a negative times negative actually makes a positive. So if you have this binomial with the subtraction sign squared like this, I can use the same pattern, but I got to remember that the middle term is actually going to be negative. So you're going to square the x, there's x squared. You're going to multiply the negative 1 times the 1. I'm sorry. You're going to multiply the negative 1 times the x and double it. In other words, multiply by 2. Negative 1x times 2. So that's where you're going to get this negative 2x from. And then you're going to square that 1. 1 squared is 1, and you end up with that right there. So x squared minus 2x plus 1. So when I multiply x minus 3 squared, I got to remember there's 3 terms. And the middle term is going to be negative. So what I can pick up on is the first time you square the x, it's x squared. You go 3 times x is 3x times 2 is 6x. But you got to remember that it's actually a negative, so it's a negative 6x there. And then if you square the 3, it's going to give you then that 9, positive 9. So it should look something like that. So there's a couple ways to explain that, but it's kind of how that works there. So there are a couple of special patterns that we can kind of deal with in this. You know, there's the a squared minus the b squared formula, but it has to look like this. I probably did that backwards. Let me go the other way around. So if you had something that looks like this, x minus, I'm sorry, let's try that again. I'm talking about the formula. So the formula says if you have a minus b times a plus b, then this is called a difference of squares. So you square and put a subtraction sign between them. You also have the perfect square, a plus b squared. If it looks like that, then your answer is going to look like this, a squared plus 2ab plus this b squared. And then if we have this a minus b squared, you're going to have this a squared minus this 2ab plus b squared. So those are some formulas that you can apply if you have strong memory with math. Well, that concludes this lesson. I hope that's going to be useful, and it'll be loaded up on the video lessons file. Take care.